Only for sake of formality you are doing this. And those who are present for the lecture but not given the test, I have marked their absentee for yesterday's lecture. So remember this also. Hmm? And the test was very easy. There was not a big deal in that. If the questions was very easy, still I don't know what was the reason that you are not getting the marks. Okay, so yesterday we have finished our third chapter. So this was the last chapter from the first section. Okay, so about first section we have finished. So instead of going or moving forward, going for the next chapters, today onwards I'm going to start the revision of the all the chapters. Okay, so that if you anybody is having any doubt, you can ask. So the pattern of the lecture from today onwards will be a revision of the earlier part plus the gate questions whatever asked regarding the any particular chapter or any particular point. If there is any gate question was there, so I'm going to cover that and plus the practicals which are related with the particular chapter. So, regarding the first chapter, we are having one practical, but for that we need two machine connection. So that is not possible to show me right now or at this platform. So from second chapter, we are having the practicals, which I can show you. Already I have started. Still the remaining programs we will cover while we will move to the chapter number 2. So that will be the pattern from today onwards. Also, uh, there will be one test, means odd even week. There will be one test. In that test, the questions will be based on the gate questions, also your university questions. Okay, so that test I'm going to conduct henceforth. Okay, so yesterday was the first test. According to me, I think you were not that much serious. So I have not seen any of your marks to your parents, but henceforth every test mark will be sent to your parents. Okay, so be aware, and not only my subject, maybe every teacher will send it. Hmm? So today onwards, we are going to start the revision. If anybody is having any problem, please let me know at that point only. Okay.
Ma'am, your voice is not audible loudly.
Okay. So today we are going to start the chapter number 1, a revision of the chapter number 1. So the chapter number 1 in this chapter, the name of the chapter was the data communication fundamentals. In this chapter, we are going to see all the basic parts related with the data communication. So let's start. So first, what is mean by the data communication? So it is nothing but the exchange of the data between the source and the receiver by using some transmission medium. For example, it can be a wire or wireless communication. So you might be now you are having some idea that how communication is happening between the two parties, because lots of terms we have seen where the communication is happening. Yeah, up to the third chapter, how sender is sending the data, how the error is being checked, how data is reaching to the receiver. So all that part we have seen. So now it is quite easy for you to relate the terms. Okay, I hope. So data communication is nothing but it is the sending or the exchange of the data between the two parties or two nodes, any two nodes. Then it is called as a data communication. To send and receive the data, we need some medium which is called as a transmission medium, wired or wireless. So that is nothing but the data communication. These are the some terms or the models which are required for the communication. Okay? So transmitter, then transmission medium and the receiver. So transmitter is nothing but who is responsible to take the data from the source and who generates the signals for that data. So originally data is in the formats of the 1010, and for that signals are generated. Okay. How many types of the signals are there? Can anybody tell? And which are what are the names of that signal? Yes. How many types of the signals are there?
Two types.
Which are those?
Transmitted
Digital and
signal
analog.
No, digital signal and analog signal. These are
And
the two types of the signal. Okay. Digital signal means square waves are there, and analog signal means continuous waves are there. So that is the two types of the signals. Okay. So for 1010 data, some signals are generated and that signal travels through some transmission medium, wire or wireless. And this is the receiver side. So receiver will get a signal or the data and receiver will give the output to the end user. So this is the general communication model through which the data is sent from sender and it reaches to the receiver. Okay. Now, so what is meant by the source, then transmitter, transmission system, receiver, and the destination? That part is there in the first diagram itself. Okay. So next term and the important term is the what is meant by the computer network. Okay. So in general, when number of computers are grouped or they are linked with each other, and linking of the each other enables sending of the data or sharing of the resources or the application, then that is called as an computer network. Okay. So it is a group of computers which are linked with each other to enable computers to communicate with each other and share some data, resources and the application, then it form a computer network. Okay. Now it is the computer network is of four types, or it is divided on the in four types: LAN, MAN, WAN, and the FAN. Okay. So, can anybody tell what is this LAN, WAN, MAN, and FAN?
LAN is local area
Local
network.
area network. Okay. What is the difference between these?
According to the number of computers connected in it,
Instead of
they are
yes,
type.
yes. Instead of numbers, we can say that according to the size of the area, right? Because LAN is mostly used for small size of the area. Okay. Similarly, MAN is used in metropolitan cities. Okay. Then WAN is wireless, means if two buildings should be connected with each other, means hardly 5-10 kilometer distance is there, then we can use the MAN. And the PAN stands for personal area network. Means I suppose I have connected my mobile with my laptop through then, and suppose I'm sending some files from mobile to the laptop, then it is my personal network. So that comes under a PAN. So these are the four types of the networks which are used: LAN, MAN, WAN, and PAN. Okay. So LAN stands for local area network. So when the area is limited or it is short, then LAN is used. Then MAN is metropolitan area network. When different or the larger geographical area is there, then MAN is used. Then WAN is used. Suppose we want to create a network in two states or two buildings. Then WAN is used, and last one is the PAN, so personal area network. Okay, so these are the four types of the network, so computer network. The next type is the data transmission. Okay, so data transmission is a means of transmitting digital or analog data over a communication medium to one or more devices. Okay, so it is nothing but how communication is happening between the two devices by using which type of communication. That is nothing but the data transmission. So generally communication can be point to point or multi-point communication. Okay, so let's see what is this point to point and multi-point communication. So this is the exact example for point to point and multi-point communication. So point to point communication means what? When the data is shared between exactly two nodes, then it is called as a point to point communication. So you can see here, this is one node and this is the second node. And the data is shared between these exactly two nodes by using only one medium. Then it is called as a point to point communication. Okay, and multi-point communication means what? The data is shared among the different nodes. Okay, the medium is same. Okay, and the same data is shared or this same medium is used by different nodes. Then it is called as a multi-point communication. Can anybody tell example of these two, point to point and multi-point communication? Hmm? Yes,
पॉइंट टू पॉइंट मध्ये आपले मोबाईल फोन वगैरे येतात
and
आणि
multi-point.
FM वगैरे रेडिओ.
Yeah, correct. So mobile communication means what? We are sending suppose one-to-one communication. Call केलाय मी कुणाला तरी. Then it is a point to point ना because I'm talking with the only one person. So exact two users are there which are using the same medium. And multi-point means as he told radio broadcasting because at a time thousands of users are listening the same song or same speech whatever it is. Okay, so that is nothing but the multi-point communication. Okay, so this is the real time real example. Then next is the signal. So already signal, what is this we have seen. So signals are generated for the data. Okay, so data is in which format? Binary format 101010 likewise. So for that data directly we can't, that data is not traveling through the medium. आपण काय म्हणतो की डेटा कशातनं जातोय वायर मधून जातोय whether 1010 will go through wire. No, so for that data some signal are generated and these are nothing but the analog and digital signal. Okay, so what is this analog signal? So as I told you, these are continuous waveform and these are mostly depend upon amplitude, frequency and phase. These on these three terms it is depending upon the analog signal. And digital signals are discrete waveforms means 1010 likewise. So generally for the binary data digital signals are generated or these are represented like this, but we can convert this digital signal into analog signals also. Okay, so these are the two main types of the signal, analog signal and the digital signal. Then transmission medium. Transmission medium means through which or by using which media the data is being sent. That is nothing but the transmission medium. Okay, so transmission medium is divided into two types, guided and unguided medium. Guided medium means what? So a fixed path is decided for transmission of the data. Okay, for example, by using some wires, twisted pair, coaxial. What are these wires? How they look? We have seen. So next part is that one. But what is mean by the guided medium? Guide Guided medium is what? Fixed path is decided, and by using that physical path only, the data is being sent or data is transmitted between the two nodes. And unguided means there is no fixed path for transmission of the data. Data can travel by using any of the way. So that is okay, which is also we call it as a wireless medium. So these are the two mediums through which data is being transmitted. We have to see mostly this part, guided medium. These three types of the cables we are going to see, or these are there in our syllabus. So let's see what is mean by the twisted pair cable. So twisted pair cable, it looks like this. Mostly it is used in LAN cables. So LAN cable, sorry, in twisted cable, there are generally 8 and they form 4 groups. Okay, so you can see here total 8 colored cables are there. Okay, and they are twisted with each other to form one group. And this pairing is also fixed. Okay, हे जे pair केलेले आहे ते fixed असतात. Okay, for example, white orange cable is paired with the orange cable, then white blue cable is or twisted with the blue cable. So this twisting is fixed, and accordingly the wire is made. So twisted pair cable. So as I told you, this is mostly used in the LANs or the telephone lines. You might have seen it. What is the reason for the twisting? The twist का केलेला आहे? So the reason is to avoid the external noise, or to reduce the external effects on the medium. So that is the main reason behind twisting of the pair. Again, there are types of the twisted pair: unshielded twisted pair and shielded twisted pair. Shield in the sense extra cover. Okay, so some wires comes as a unshielded and some wires comes as a shielded twisted pair. Okay, so these are looks like this. The difference is only one more extra shield or cover is added on these cables, and some cables are without shield. That is the only difference between these two. So you can see here shielded twisted pair. The working or other things are same. Shield is extra shield is added again to provide the security or external effects, to avoid the external effects or noise. So for that purpose, shield is added. So these are the two types of the uh, twisted pair cable. Then next comes is the coaxial cable. So it looks like this. Okay. So these are the certain layers which are added on the pair, and exactly from this position your or the data is being traveled. So this is the coaxial cable, and it is, or we have seen this cable in our TV. So that is the example. So these are the conductors, and every conductor, use of the every conductor we have seen. Okay, so this is coaxial cable. So in cable TV networks, it is used in traditional Ethernet lines. It is used and in LAN. So these are the uses of the coaxial cable. And last one is the optical fiber cable. So this is the optical fiber cable, where, or it is a very thin cable, or we can say it is a plastic cover, and at the tip of this cable only data travels. So these cables are mostly used in medical field. So that is the use of this optical fiber cable. Okay. So these are the three types of the cables. First one was the twisted pair, coaxial, and optical fiber cable. So these are the three types of guided medium. Hmm. Then next is the transmission modes. Okay, so these three types of the transmission modes are there: simplex transmission, half duplex transmission, and full duplex transmission. Okay, So transmission modes means transferring of data between the two devices. Generally, in the transmission mode, we can say that it decides the role of the nodes or role of the devices. Who will act as a sender, who will act as a receiver. That is decided in the transmission mode. Okay, and these are the three types: simplex, half duplex, and the full duplex. Okay, so let's see what is simplex transmission. Can anybody elaborate? What is this? आठवते का काही?
Only one directional communication.
Only one direction. Okay. What is half duplex?
At a time, only sender can only send data and receiver can accept.
हाँ.
That time, other PC or server cannot send data.
Okay. Any other answer for half duplex? थोडंसं चुकलं. Half duplex. Hmm? Half duplex. Simplex transmission, he told correctly that sender is allowed to only send the data. Okay, means one machine will only send the data and second will only receive the data. That is the simplex transmission. In half duplex transmission, how the communication is happening? You can see the diagram now. A is sending the data, B is receiving the data. In other way, A can also receive the data and B can also send the data. Means A will act as sender as well as receiver, but one role should be played at a single time, either sender or receiver. That is nothing but the half duplex.
Only one
Okay.
party
So,
can talk at a time.
yes, only one part. For this, I have told one example also. आठवते का काही?
Walkie-talkie.
Yes, walkie-talkie was the correct example for this half duplex transmission. Hmm? So this is the half duplex, and third one was the full duplex transmission. This both can send the data as well as receive the data at a time. So that is nothing but the full duplex transmission. So these are the modes of the transmission where we decide the role of the each node. Who will send, who will receive, what should be the transmission mode. So that is being decided. Simplex transmission, half duplex and full duplex. Actually in practical it get more elaborated because we are going to execute these on two separate machines. We are going to provide the role of sender as well as receiver for two machines. But let it be, we'll see when it comes to exact evaluation. Okay, so these are the three. Up till now, any doubt? Hmm?
No, ma'am.
No.
No, ma'am.
समजलंय सगळं? Girls?
No, ma'am.
Yes, ma'am.
Yes, समजले. No मॅम म्हणजे समजलं नाही. Yes मॅम म्हणजे समजलं काय? I don't know. Any doubt?
No doubt.
No
No,
doubt.
ma'am.
Okay. So this was the first day PPT that I have done. Let me take the second day PPT. Next point was the transmission impairments. So what is transmission impairment? हाँ, impairment से meaning है
ते external disturbances येतात त्याच्यात.
yes. Impairments means due to some cause. It can be anything. external, internal, whatever, the data is being affected. That is nothing but the impairments, okay, transmission impairments. So, in transmission impairments, we have seen some of the types of the impairments. Before that, I'll read the definition. So, signal travels through the transmission medium which are not perfect. Okay, so no signal, not perfect in the sense it may get affected. So original signal is not received by the receiver. Signal is not received means original data is not reaching to the end user or the receiver. The imperfection causes a signal impairment. Okay, so this means that the signal at the beginning of the medium is not the same as the signal of the end of the medium. So what is sent is not exactly received by the receiver. Okay. So there are some consequences for digital signal. There may occur a bit error. Means कशामुळे सिग्नल इम्पेअरमेंट होतो तर डिजिटल सिग्नल मध्ये काय होतं बिट एरर वनचं झिरो झिरोचं वन लाईक आणि अॅनालॉग सिग्नल मध्ये इट डिग्रेड्स द क्वालिटी ऑफ द सिग्नल सिग्नलची क्वालिटी जर चेंज झाली देन इम्पेअरमेंट कॅन हॅपन okay so due to these two reasons we are going to see this concept okay transmission impairment so these are the three transmission impairment causes attenuation, distortion, and the noise. Attenuation, delay, distortion is also called, and the noise, third one. Now let's see what is mean by the attenuation. So attenuation means it is in loss of energy. So generally attenuation is happen when the data is traveling through a medium and the distance is too large. Because when the distance is too large, at that time there are very large chances of being the data corrupted or affected. So attenuation is happening when the distance is too large. So when a signal, simple or composite, travels through a medium, it loses some of its energy in overcoming the resistance of the medium. Means the strength of the signal is getting reduced. This is why a wire carrying electric signal gets warm if not after a while. Okay, so this is the example. ठीक आहे आपण ज्यावेळेस चार्जर लावतो त्यावेळेस बघा खूप वेळ झाला असेल तर काय होतं चार्जर थोडासा गरम होतो ऑल्सो आपल्या ह्याचं लॅपटॉपच्या चार्जरला पण सेम असतं तर खूप वेळ आपण चार्ज केला लॅपटॉप तर हे ओव्हरहीट होतं so that is the example of the attenuation and due to which the data is or the signal is being affected. So this is called as an attenuation, but this should be reduced. Attenuation should be reduced or it can be reduced by using some use of the amplifiers. Okay, by using some of the amplifiers. So what is this amplifiers? These are nothing but it acts as a boosting energy for that particular signal. Means if the signal is attenuated, okay, use of the amplifier may get or may give the original signal. It is definite that this will not match to the exactly original signal, but we can gain some of the original signal by using the amplifiers. Okay, so amplifiers are used after some what we can say some distances. These such type of amplifiers are added to your transmission medium. Yes, you can see here point one, then point two, where the attenuation means signal is getting varied or it is getting affected. So once the signal is affected, use of the amplifier can recover that signal. So that is nothing but the use of the amplifier to reduce the effect of the attenuation. Okay, so that I have told. How to measure the attenuation? This we have seen. Is whether your signal is affected or not, or whether there is a loss of the signal or gain of the signal. That is measured by using this formula. It is generally unit of this is decibel, which is equals to 10 log to the base 2 base 10 P2 by P1. P2 is output signal, P1 is input signal. So by using this formula, we can calculate whether the signal is lost or it has gained some energy. So that is nothing but this is the formula. We have seen some of the examples of this also. So this was the example that we have seen. Okay, so when the answer comes as a minus 3, so it means that there is a loss of energy. Okay, आठवते का example?
Yes, ma'am.
सगळ्यांना.
Yes, ma'am.
Okay, then
Yes, ma'am.
such examples also we have seen, three examples we have seen on this. So next impairment is the distortion. Okay, which is also called as a delay distortion. Delay distortion means delay distortion means that the signal changes its form or shape. Signal changes its form or shape. That is nothing but the distortion. The distortion can occur in composite signal made of different frequencies. Okay, due to different frequencies, the signal or the original signal is not same as a or it is not same or it is not received exactly as it is sent by the sender. Okay, so that is nothing but the distortion. So this is the example of the distortion. So a small change in a signal can make, or we can say that that is a distortion. A small change. So you can see here. So this example. So this signal is varied only here. फक्त इथं हा व्हॅरी झालेला and due to this small variation, this distortion gate happen on this signal. Okay, so any small change in a signal can raise to the distortion or the delay distortion. So delay distortion, we can say that it is nothing but the signal which is sent by the sender, right? And it is or it is not reaching in a proper time. Then we can say that it is a delay distortion, and due to which the signal is getting varied. Okay, so that is, and mostly this delay distortion is happening due to the speed of the sender and the receiver. Maybe sender too fast असतं आणि रिसिव्हर तेवढा रिसिव्ह करू शकत नाही. त्याच्यामुळे काय होतं तर ह्या सिग्नल मध्ये व्हेरिएशन येऊ शकतात. And such variations are called as a distortion. Okay, so that is the second type of the impairments, and the third one is the noise. So noise is nothing but it is an unwanted signal which is there along with the original signal. So that is called as a noise. Okay, noise means काय तर काहीतरी इफेक्ट झालेला असतो सिग्नल मध्ये त्याच्यामुळं वेगळे सिग्नल जनरेट होतात बट ओरिजिनल सिग्नल्स पण असतात. So that is nothing but the noise. Okay, so there some examples are hit sound in radio receivers, then burst sound of the telephone conversation, then flickers in television receivers. So these are the examples of the noise. There are certain types of the noise: thermal noise, industrial noise, crosstalk, and impulse noise. Okay, so thermal noise, it is a random noise of electrons in the wire which creates an extra signal. Okay, so that is nothing but the thermal noise. It is also called as a white noise. Okay, it is also called as a white noise. Then industrial noise from motors or appliances. Device act as a transmitter antenna and medium at the as the receiving antenna, and such noises are called as the induced noise. Crosstalk is there between the when the two wires are getting affected with each other, then crosstalk happens. And impulse noise is nothing but sudden change in a signal is called as an impulse noise. Okay, so that is, these are the types of the noise which we have seen. Then comes the SNR. So that is nothing but the signal to noise ratio. SNR stands for signal to noise ratio. So what is the signal to noise ratio? So it is actually we need this SNR for one of the formula that we have seen, that is to measure the capacity of the channel, and that was the which was the formula where we have used a two formulas we have seen, Nyquist and Shannon capacity formula. So SNR is used in which formula? Hmm? कुठल्या फॉर्म्युला मध्ये लागतं SNR?
SNRDB.
SNR DBS ना, पण कोणत्या फॉर्म्युला मध्ये लागते आपल्याला? आपण दोन फॉर्म्युले बघितलेले आहेत, नायक्विस्ट कपॅसिटी फॉर्म्युला आणि शॅनॉन कपॅसिटी फॉर्म्युला. या दोन्ही पैकी हा फॉर्म्युला आपण हे टर्म कुठे यूज केलेले आहे? Okay, it is used in the Shannon capacity formula. Remember, SNR is required for Shannon capacity formula. So what towards these formulas? So capacity of the channel means what? Capacity of the channel means what? What will be the maximum rate of a channel to travel the data? Means maximum एखादा channel किती data travel करून घेऊ शकतो? That is nothing but the capacity of the channel. Okay. So it is nothing but the capacity of the transmission medium, means how much data can hold by the particular channel. That is decided by the capacity of a channel. So for this we have we need to see these two formulas, Nyquist capacity formula and Shannon capacity formula. But before that, these terms we have explained what is mean by the bandwidth, what is mean by the signal level, and all. So what is bandwidth? It is nothing but the maximum data transfer rate of a network or the internet connection. Is what will be the rate of the data. Maximum किती रेटने डेटा जाऊ शकतो. That is nothing but the bandwidth. And signal levels means what? It is nothing but the which level is used to send the data. 1 0 for 1 0, or the data is 110010 ह्या फॉर्मॅट मध्ये आहे. So can anybody tell which is good? Whether the low signal level is good or high signal level is good? In case of the Nyquist formula, this one. Okay, this is the medium. हे मीडियम आहे, याच्या थ्रू आपला डेटा जातो. याच्यामध्ये ह्याचे लेवल्स आपण म्हणतो. 1 असेल तर 1 किंवा 0 जातं, 2 असेल तर 1100 हे कॉम्बिनेशन जातं, 3 असेल तर 111000 हे कॉम्बिनेशन जातं. So in Nyquist formula, which is better to avoid the error, whether the low signal level is better or high signal level is better?
Ma'am, low.
Low. Why low? What will happen?
मॅम
हा हा
कमी
yes. हा
नॉईज पण कमी असणार तेव्हा.
नॉईज कमी असेल, पण जर मी वाढवलं तर काय होतं? कशामुळे नॉईज इन्क्रीज होतं? हिअर काय रिझन आहे की इथं जर
मॅम सिग्नल इन्क्रीज झाला तर नॉईज पण इन्क्रीज होईल.
सिग्नल इन्क्रीज झालं तर नाही. इथं सॉरी म्हणजे एक मिनिट, एक सेकंड शो यू. Here, this is my signal, or this is my medium. Sorry, this is my medium. याच्यामधून काय जाणार आहे माझा डेटा जाणार. दिस इज द मॅक्सिमम width of my medium, we can say. So through this medium I'm sending, suppose my signal level is 1. So what I will send 1 0 1 0. So my data will travel like this. If my signal level is 1, then it is very easy and feasible to travel through this medium, because 1 and 0 at a time, एक 1 z or 0 z. So it is very easy. Now suppose I have increased my signal level to 2. So what will be my data? 1 1, then 0 0 1 0. Likewise data will be there. Now suppose I have increased my level to 3. So what will happen? What will be combination? Triple 1, then triple 0, then 1 1 0. Likewise my data will be there. It means that as I'm going to increase these levels like this and so on, it will reduce the distance between these two, and within this medium or within this same medium the data will be too much. Okay, and due to this the noise or the chances of the noise are getting increased. That's why according to the Nyquist capacity formula, this signal level should be minimum. But what this minimum means exactly, so that is given over this formula. It is exactly 2B. 2B means B stands for bandwidth. So it should be a double of its bandwidth maximum, not more than that. So that is nothing, or that is the reason of keeping this signal level minimum. ओके, बिकॉज द जसं आपण वाढवत जाऊ, वी कॅन टेक अ सिम्पल एक्झाम्पल ना, एका क्लासच्या डोर मधून एक जण इझिली जाऊ शकतो, 2 जण जाऊ शकतील, 3 जण जातील, बट वेदर इट इज पॉसिबल बाय युझिंग द सिंगल डोअर 10 or 20 people will go easily at the same time? No, it is not possible, or it is not feasible, we can say. Huh? So, to reduce such consequences, it is decided or it is given by the Nyquist that this data or the signal level should be minimum. And minimum in the sense, we can keep to B or the double of its bandwidth, that much signal levels only, according to the Nyquist formula. So to decide the channel capacity, we are having these two formulas, Nyquist and the Shannon capacity formula. Nyquist formula is this one. P is equals to 2B log to the base 2 raised to N. N stands for level of signal, what we have discussed now. B stands for bandwidth, and this is the formula. So it will give you the is the capacity of the channel. So for this we have seen this example. Okay, lots of example we have seen on this. Then next is the Shannon capacity formula. So this is the second scientist who has given how to decide the capacity of the channel by if the channel is off or it is having the noise. In case of the Nyquist formula, it is mainly decided or it is mainly given for noiseless channel. And Shannon capacity formula, it is decided or it is used for the noise purpose. So the formula is C is equals to B log to the base to 1 plus SNR. SNR stands for signal to noise ratio. It is mostly given, and from this we have to calculate the capacity of the channel. Okay. So these are the some of the examples that we have seen already. So this was the related with the these two formula. This one more term we have seen, that is nothing but the round trip propagation delay. So it is nothing but it is a time. In short, I'll tell you what is mean by the round trip propagation delay, which is also called as the RTT. The questions are asked on this for the gate question paper. Okay, we have discussed this also. It is discussed over here. So RTT means what? The once the signal is sent, it will reach to the receiver. Okay, but if receiver again sends that particular data back to the sender, then this whole time is called as a RTT or the round trip propagation delay. Sender एकदा डेटा सेंड करतो तो रिसीव्हरला मिळतो, पण रिसिव्हर काही कारणास्तव जर त्यांना तो डेटा अगेन रिसेंड केला कोणाला सेंडरला तर हा सगळा टाइम काय म्हणतो आपण तर दिस होल टाइम इज कॉल्ड एज अ राउंड ट्रिप प्रोपगेशन डिले. Okay, so this was the this is taken over here because these some of the formulas are required there. What is meant by the bandwidth, what is meant by the capacity. That's why I have taken this example over here. Okay, so this is the example. We'll discuss this example in next lecture because one more example is there related with this round trip. So I'll take that in next lecture. Okay. So up till this, is anybody is having any problem? Yes, any term. So what we have seen in today's lecture that first chapter revision we have started. So we have seen what is meant by the data communication, what is meant by the transmission medium, which are the types of the guided medium, then transmission impairment, then these two formulas. Okay. Anybody is having any problem? No, I think no problem. Okay, so we'll stop here. The presentation once.
No, ma'am. No problem. Yes, number one,
Yes, ma'am.
two,
Yes, ma'am.
three,
Yes, ma'am.
four. Rule number four, five. Rule number four is present. No. Okay, five. Rule number five is six,
Present, ma'am.
seven. Rule number seven, eight. Pallavi, nine,
Present, ma'am.
10,
Yes, ma'am.
11, and 12. Rule number 12, Divya, 13,
Yes,
14,
ma'am.
15,
Yes, ma'am.
Neha, 16.
Yes, ma'am.
15
Yes,
present.
15 marks, right? 16.
16 present.
Yes, 17,
Yes, ma'am.
17. You are absent for the
Yes,
last
ma'am.
lecture. Yesterday, why?
Ma'am, network problem.
Only one solution, huh? Only one reason. Network problem. Rule number 18,
Sorry, ma'am.
Present, ma'am.
8, 19. Rule number 19,
Present, ma'am. Present.
20,
Present, ma'am.
21,
Present.
22,